Imagine you're stranded in the middle of the desert, desperately searching for water to drink. The nearest body of water is miles away, yet you're surrounded by other life forms, which, by evidence of their existence, have found some way to obtain enough water to survive. These organisms rely on an invisible yet ubiquitous source of water, even available in the most arid deserts, the tiny water droplets in the air that make up fog. Any successful fog water collection system in desert organisms or human industry must fulfill two basic criteria. It must first quickly condense water from the air, and it must then quickly move that water away, or else no new water will condense. The surface needs to be sticky to water in the air, but not too sticky to condensed water. As you might expect, it is hard to find a surface which can excel at one of these criteria without being worse at the other. Scientists look to nature for inspiration for new, more efficient devices. However, humans need far more water to sustain their communities than individual organisms do to sustain themselves. Simply copying plants, animals, and plants is not sufficient. Yahui Su, a researcher at Anhui University in China, has found a way to make water collection more efficient by combining nature's tricks, making a device inspired by the desert beetle and the cactus. To obtain water, desert dwelling creatures rely on microscopic structures on the surfaces of their bodies to force water to condense out of thin air. For example, some beetles in the Namib Desert engage what is known as fog basking behavior. At dawn, the beetles will tilt their bodies toward the encroaching morning fog, waiting for it to condense into larger droplets and be funneled down their backs. Close inspection of the beetles' backs reveals a series of alternating bumps and throws in a random pattern. The top of each bump is covered in a hydrophilic coating. Water will preferentially absorb there, like a t shirt soaking in the rain. The throws between these bumps are hydrophobic, like a raincoat, which encourages the droplet to continue falling down the incline of the beetle's back right into its mouth. The cactus has also developed a specialized method of water collection. The same spiky spines that protect the cactus from being eaten by other thirsty desert dwellers also act like tiny water antennae. Invisible barbs at the tip of each cactus spine forces the water, and then the spine drives the droplets towards the body of the plant, even if the spine is pointing downward. Yahui adapted lessons from the cactus and the beetle and created an aluminium foil capable of pulling water from fog.